So yesterday we spent some time on identifying and describing patterns. What's the benefit of that? Number one, once we establish a pattern, we don't have to do as much work, so we can just start plugging numbers in. So I'm on page 3 and problem 3, and we are going to be using a graph. All right, the graph over here, the graph shows the total cost of platies at the aquarium shop. Use a table to find the cost of 6 platies. All right, so we're over here. The data indicates this right here. At 1, at 2, at 3, it gives me the total cost for each one. Our goal, of course, is what happens if I buy 6? How much am I going to pay? But first and foremost, we're going to circle the description of the input value. Please circle that word, input value. And we are going to write down, this is also known, not just the input value, it's also called the independent variable. Independent variable. I'll explain that momentarily. All right. All the values together is called the domain. All the values together are called the domain, the types of numbers that I'm putting in. Okay? Each one is called an input value. Each one, the whole thing is called an independent variable. All the numbers together are called the domain. We'll unpack that as we go. But let's see why it's called the independent variable. Do you spend money on nothing? No, not really. Well, yeah, I mean, I'm sure some of us waste our money, but that's not the point. Do I go in to spend money, or am I going in to get platies?
To spend money.
I mean, I have to, but my goal is to get platies. And as a result, once I get them, it affects how much money is coming out. My decision here affects that. Now, yes, it's true. Technically, I could say I only have $70, so that limits it. But that only puts a limit, really. If I'm coming in to get it, this is the independent. The money depends on how many I buy. The money depends on how many I buy. Now, sometimes you can actually switch those in real-life situations. But as it's set up in this, this is going to be called my input or independent variable. Okay, so let's see here. What's the input? That is the number of platies that you purchase. So I'll put that over here in the left column. Next, the output, therefore, is going to be the total cost. Total cost, not in euros, but in dollars, as it says, just in case you're confused. Some things to consider is that the input is a 1, and it's going to show up in the column there as well. My input is a 2. It's going to show up in this column. Over here, my third is going to be right there. And the same thing goes true here. My 6 here is going to show up there as well. So the point of the process column is to take the values that I'm putting in, do something with it, and out comes my total cost. So, but if we look at the table, we can actually fill the table in without processing anything. All we have to do is look right here. 1 gives me $2. Buying 1 platy gives me costs me $2. Buying 2 costs me $4. So let me go ahead and write those in here. Buying 1 gives me 2. Buying 2 gives me or charges me $4. So what about 6? What's this one going to give me? Well, if we follow the pattern, notice it's going to be somewhere up here, like that. And 6 is going to go all the way up to here and be out there. Now, this is beyond our scale. It's too high. We can't actually determine it, but that's what we're doing here. Notice how do I get from a 1 to a 2? Notice that I am, each time, doubling. Times 2, times 2, times 2. So in the end, for 6, it's going to cost me $12. So we're establishing a pattern. And now, when we abstract that, we call this the algebraic notation. We input, remember that the input here is n. The amount that it changes by is it doubles. So when I combine that, simplify, etc., my answer over here is 2n. In other words, double. 10 fish cost $20. 100 fish cost $200. Now I'm going to do one thing, which is a common thing that people like to do, and I need you to describe what's wrong with what I just did. Okay, so a lot of people like to do this. Connect the dots, la, la, la. And then, of course, since we are geometers, we put an arrow on the ends because lines go on forever. Take a moment with your partner to explain. And there are at least 3 things wrong. What is wrong with what I just did? And not just mathematically wrong, but practically in real life, there are potentially 3 bad things or 3 wrong things or incorrect things going on. Chat. So now that you've taken some time to look at 3 potential issues, let's go. Our first one has to do with what happens if I want to buy this many fish right here. So this many fish here is a funny number because that is 1.5 fish. And of course, that does give me a number. It gives me 3. So yay, I buy 1.5 fish and it's going to cost me $3. Why does that not make sense? Because buying 1.5 fish is probably not in most people's head when they walk in to buy fish. So we're only considering the whole numbers. Another consideration is here, the negative numbers. Notice -1 means that I sell fish. I am getting rid of fish, which means now I become the supplier, which is not the case. I'm not the supplier, I'm the consumer, which is me over in this quadrant. And lastly, what if we go way over to like 1,000? Will I expect to spend $2,000? And the answer is no. Because we like Costco, BJ's, and Sam's Club, I do not expect there to be a direct relation here. I now expect a good deal. Give it to me for $1,500, huh? So, at some point in time, bulk will probably break down. So let's continue to address some of these. In the table, when the input value is 6, the output value is 12. Next, the expression 2n, 2n, 3n describes the cost of 1, 2, or n. So what's the situation? Well, when I put in n, out comes 2n. I double the number to get the cost. So at the aquarium, the cost for 6 platies is not 6, no, it's double, $12. Now let's continue on page 4. We're asked to make a table to represent each pattern. So making a table generally means I'm going to make a T-chart or some other form of that. Wait a tick, I only have the output information here, which means I can put the 2, the 4, the 6, and the 8 in this column, but what goes over in this column right here? What's the input? Well, the answer to that is just simply, what term is it? My first term is a 2. My second term is a 4. My third term, so in other words, it's my counting numbers over here. Now that is, I'm done with this. It asked me to do a table. But let's just take it to the next level because we can. And what happens if I were to figure out if I put in n? How does it change? Well, notice for each thing, to get from a 1 to a 2, from a 1 to a 2 to the 4, a 3 to the 6, what am I doing? I multiply everything by 2. So my output here would be 2n. Very similar to the Plattis situation. Well, the same thing over here. First I have to figure out what these represent. Counting this up is a 3. This is 3 here, and that's 3 there, so that's a 6. Group of 3s, just because it's a little bit easier to see. 9, and you could even predict what's going to come next, but just by counting here, I have 4 groups of 3, which is a 12. So when I make my table of values, I have an input and I have an output. The input would be my first term, second term, third term, fourth term, and my output, so let me label my table there. Label my table. There you have it. So out comes a 3, out comes a 6, 9, and 12. Again, let's take it to the next level. So if I were to input an n, what would I output? Again, from a 4 to a 12, a 3 to a 9, I triple this. All right, the next part for you is to go on down here and work through this lesson check. The answers are posted online, so please go ahead and double check. Notice that some of you may get different answers in this case.